Alright, what's up guys? In this video, I'm going to pick up with some multivariable calculus. We're going to be talking about volume integrals. So we're just asked to use this triple integral to use a triple integral to find the volume of the solid bounded by the two graphs of the given equations. Okay, so we got our triple integral here from 0 to question mark, 0 to question mark, 0 to question mark, dz, dy, dx. So basically, all we really have to do, much of this problem is kind of already done for us. All we have to do is find the upper limit of integration for each of these integrals. The graph of these two equations that we have down here, I couldn't draw that graph, so that's why we don't have it. So we can just kind of do a little bit of a mental visualization, I guess. So basically all we need to do is find those upper limits of integration. Now it's going to be easy to do for z, it'll be easy to do for y, because again we already know what the lower limits are going to be. So we just need to find the upper limit of integration for x, and then it's just a triple integral after that, and it's going to be integrated dz, dy, dx. So we know our range for z already, so let's write that down. So we know our range for z. So the range for z in this case, z is going to be in between 0 and 3x squared. We also know the range for y. So the range for y, well, y is going to be between 0 and 5 minus 5x. And for the upper limit of integration with respect to x, well, notice that y was equal to 5 minus 5x. So we basically just solve that for solve for x by setting 5 minus 5x equal to 0. Solving for x will get the upper limit here. And so clearly what we'll do is subtract 5 from both sides. So we'll get 5 minus 5x minus 5 is equal to 0 minus 5. And this gives us negative 5x is equal to negative 5. We'll divide both sides by negative 5. And we'll just simply get that x is equal to positive 1. And now all we have to do is set up the triple integral. So this is going to be our ranges now. Write them in kind of like a set notation essentially. So that's for z, this would be for y, and the ranges for x will be from 0 to 1. Okay, so we got v is equal to, now remember we're integrating this dz, dy, dx, so we have to make sure that the integrals are matched up with the correct differential. So that means the outermost integral here will be from 0 to 1. The innermost integral here will be from 0 to 5 minus 5x. And then the closest integral to the integrand will be from 0 to 3x squared. And we're integrating dz, dy, dx. Okay, so with a triple integral, much like for the doubles, we'll start by integrating with respect to z, treating the other two variables as constants. Then we'll integrate with respect to y, then we'll integrate with respect to x. And we work our way from the innermost integral here to the outermost one. And that's kind of how it works. Okay. So from 0 to 3x squared, we're integrating dz. Okay, well, that's just going to give us z evaluated from 0 to 3x squared. And we know we'll just get 3x squared. So now we're down to our double integral now. Let me get another sheet. Okay, so we're down to our double integral, and now our double integral becomes the integral from 0 to 1, the integral from 0 to 5 minus 5x, and what we're integrating now is 3x squared dy dx. Same scenario, we'll integrate with respect to y now. So this will be from 0 to 5 minus 5x, and we got 3x squared integrated with respect to y. So since we're integrating with respect to y, not only is the 3 a constant, but so is the x. So in this case, this becomes 3x squared multiplied by y. This is going to be from 0 to 5 minus 5x. And we see what that gives us. And we'll evaluate that from 0 to 1. So if I go ahead and plug in my upper limit, obviously subbing in the lower one, which is 0, will only result in a 0. So, we're not going to be subtracting anything away. So this is just going to be 3x squared multiplied by 5 minus 5x. And now this is going to be integrated with respect to x. So as you can see here on the inside here, there's a common factor of 5. The 3 is also a constant since we're integrating with respect to x. So I'm going to take the 3 and the 5 and multiply, which I know gives me 15. So 15, which is just a constant, can be brought outside. This would be from 0 to 1. And we'll have x squared minus x to the third dx, given that we distribute in the x squared after that. Okay, so we got our 15 on the outside. That's just a constant. When we integrate x squared with respect to x, we get x cubed over 3. And this would be x to the fourth over 4. And this will be from 0 to 1. So we know that this will be 15 times, well, if I substitute in from 0 to 1 for both of these, I'll get 1/3 minus 1 over 4. And remember that 1/3 minus 1/4, that's 1 over 12, and so we'll get essentially 5 times 1 over 12, which is 15 over 12. But you always want to try to reduce as much as possible. We can divide both the numerator and denominator by 3, simply giving us 5 over 4. And that's about as far as we can go with it. So that would actually be the answer. So your final answer here, you have to set up the triple integral, and it wasn't too bad for the most part. Again, I didn't have the graph because I didn't want to draw it. And it's dz dy dx. So looks like we'll just get 5 over 4 as our answer. And that's how you do it. So that's just basically another example of evaluating a triple integral. Okay, so let me know if you have any questions about anything, and I'll try to talk about it with you. So we'll see you next time.